Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, one little character, the pipe, and how it quietly does about 4 jobs you'd otherwise handcode badly.
This is LCEL, right? LangChain Expression Language. And the smallest example is the one everybody's seen. Prompt, pipe model, pipe parser.
That's the seed. But here's the thing worth understanding, because it's the whole trick. Everything LangChain calls a runnable place in this game. Chat models, prompts, parsers, retrievers, even a plain Python function if you wrap it. And the pipe is just an operator defined on that base class. You pipe 2 runnables together, and what comes out the other side is another runnable.
So the compose thing is the same type as its parts. The chaining never breaks the contract.
Never breaks it. That's exactly it. Whatever you build, you can always invoke it, batch it, or stream it. Because the output is always one more thing that speaks the same interface. It's closed under composition, like Lego. Every brick you snap on still has studders on top.
Okay, so that's elegant on paper. What does it actually buy me at runtime?
4 execution modes, for free, the moment you have a chain. Invoke for 1 input. Batch for a whole list. Run in parallel under the hood. Stream, which hands you an iterator that yields output as it's generated, and an async version of invoke. And that uniformity is the real reason to use LCEL. Writing those 4 modes yourself for a non-trivial pipeline is a genuine pile of code, and you'll get the async and streaming bits wrong the first time.
Let me slow down on streaming because that one feels magic. The model can stream token by token, sure. But a JSO parser can't, right? JSO's invalid until the last brace.
And that's the beautiful part. LangChain figures that out for you. It looks at the chain and works out which steps can stream and which can't. The model streams, the JSO parser, which needs the whole thing to be valid before it can parse, doesn't. So you get incremental output exactly where it makes sense. And it just holds where it doesn't. You didn't write any of that logic.
Alright. The other thing I keep hearing about is fanning out. When would I reach for that?
Here's the classic case. You've got one document and you want 3 things from it. A summary, a sentiment, and some keywords. 3 separate LLM calls, but they all take the same input and they don't depend on each other. So you fan them out. Runnable parallel. Same input goes to all 3 branches. You get back a dict keyed by name. And LangChain runs them in parallel.
So 3 sequential round trips collapse into roughly 1 round trip's worth of wall clock time. That's a real latency win, not a cosmetic one.
A real one, 3 calls, 1 trip's worth of waiting. And the sibling primitive is branching. Runnable branch, which is basically LCEL's if else. You hand it a list of conditions. The first one that comes back truthy wins. And the last argument is your fallback. So you can root. If the language is SQL, run this chain. If it's Python, run that one. Otherwise, the default.
Now, batch worried me when you mentioned it runs everything in parallel. Doesn't that just nuke a rate-limited API?
It absolutely does. And this is the gotcha that's invisible in development and brutal in production. By default, batch fires all your inputs at once. Hand it 1,000. And it tries 1,000 simultaneously. And you smack straight into your provider's rate limit. The fix is one config option. Set max concurrency to say 5. And now it throttles. Easy to forget, painful to learn live.
So given all this power, when is LCEL actually the wrong tool? It can't be the answer to everything.
It isn't, and the lesson is refreshingly honest about it. If your pipeline is just call chain 1, call chain 2, call chain 3, each line feeding the next. That's perfectly good plain Python. It debugs with a normal stack trace. The type errors are obvious, and a junior on your team reads it in 10 seconds. You give a batch and stream across the whole pipeline, but you can still call them on each piece.
So the pipe earns its place specifically when you've got the parallel branches, the conditional roots, or you need streaming end-to-end across the whole thing.
That's the line exactly. And there's one more boundary. The moment your workflow grows loops, conditional reentry, or a pause to wait for a human. then LCEL starts to feel cramped. A runnable branch chained 5 deep is genuinely unreadable.
And that's the cue for LangGraph, I assume? The next chapter?
That's the cue. And there's a lovely one-line rule of thumb for knowing which you need. If you draw your workflow as a flowchart and it has a cycle in it, a loop back to an earlier step, use LangGraph. If it's a clean one-directional flow, a DAG, LCEL's perfect.
Draw the flowchart, look for a cycle. That's a great test. One sentence to take away?
The pipe composes runnables into one object that streams, batches, and runs async for free. Reach for it when you're fanning out or routing. Drop to plain Python when it's just a straight line. And switch to LangGraph the moment the flowchart loops.
Couldn't draw it better. That's the Datarekha audio guide. Catch you in the next one.